Hey everyone, Math 105. This is Lesson 4, Introduction to Equations. First thing we need to do is determine whether or not a number is a solution to an equation. As it turns out, the solutions to equations are the numbers that when you plug them in for the variables, it makes the equation true. So for the first example, we're going to test whether or not 2 is a solution to this equation. So for every instance of x, I'm going to plug in a 2. You can put it in parentheses like that, or you can just, in this case, since it's a positive number, just put the dot in between, write them either way. All right, now we use order of operations on the left, so we'll start multiplication. 16 minus 10 equals 5, and 6 does not equal 5. So we got a false statement, so that means x is not a solution to that equation. Your turn, number 1. Got 4 different equations and 4 solutions to test. So first one, we're going to test x equals 5. There's only one variable, so we'll plug it in here. All right, now evaluate here. That's 8. And 0.1 times 8 is 0.8. So we get a true statement here. That means yes, 5 is a solution to that equation. All right, part B. We have 2 instances of the variable. We're going to plug in 2 for both of those. So 6 times 2 here, plus 2 times 2 plus 3 equals 14. All right, let's see what we get. We got 2 plus 3 is 5, 6 times 2 is 12. And that's going to be 10. $22 does not equal 14, so no, 2 is not a solution to that equation. Part C. Got 12 fifths. We're going to plug it in for both of those. Now there's 2 different ways we can do this. We could plug it in for both values of x, or we can simplify first. But it's really best to just plug them in, just in case you make a mistake while simplifying. All right, now we need to multiply the numbers by the fractions. Remember to multiply by the numerator, keeping the denominator the same. 2 times 12 is 24 over 5. 3 times 12 is 36 over 5. Plus 8 equals 20. And now we already have a common denominator, so we can add these together. 24 and 36 is 60, so that's 60 over 5 plus 8 equals 20. And 60 divided by 5 is 12. So that gives us 12 plus 8 equals 20. So both sides are equal at 20. So yes, 12 fifths is a solution. So just make sure you can operate with fractions. You can do all this in your calculator. Last one, we're going to test 5 in this equation. So 7 tenths times 5 plus 1/2 equals 4. All right, so that gives us 35 over 10 here. And I want a common denominator, so I'm going to write 1/2 as 5 tenths. And then we'll add these together. 35 plus 5 gives us 40 over 10. And 4 equals 4. So that works, and yes, 5 is a solution to that equation. Now this is important because every time we solve an equation, we're going to check to make sure that we've gotten the right answer. And we'll check by plugging it back into the equation and seeing if it works. That way you should be able to detect all of your mistakes. And it's especially important to do on exams. And of course, you can always do the checking with your calculator, and that'll speed things up. So solving equations. What we want when we solve an equation is something that looks like variable equals a constant. That's what a solution looks like. So something like variable x equals a constant 8. All right, now equations, you can think of these as being a balance. All right, so we got a balance here. And we are going to start off with the assumption that these things are equal to each other. Think of these as being weights. Got 11 pounds on this side. This also is 11 pounds, just written in a little different way. So what we can do, in order to keep the equation, keep the balance level, to keep these two sides equal to each other, is we can add or subtract equal weights to both sides. So I could, if I wanted to, add 13 pounds to this side, and then add 13 pounds to that side. So if we started off with equal weights, if we had 13 pounds each side, they're still equal. So that means the equation is still equal. Both sides are still equal to each other. But if instead over here I decide to add 5 pounds, now all of a sudden this side is heavier, and our equation and our scale is going to be unbalanced. This side is going to be heavier than this side. The two sides of the equation will not be equal to each other. So if we add things to the equation, we have to make sure we add the exact same thing to both sides. And same thing works with subtraction. So second example. Right, this will be a one-step equation. Now next to the x, we're trying to get x by itself so that it looks like this, but it's got this negative 7 attached to it. So I'm going to get rid of that negative 7 by adding the opposite. Negative 7 plus 7 is 0, so we're left with just an x on the left side. 6 plus 7 is 13. All right, now if I take the 13, plug it back in here, 13 minus 7 is 6, so that is correct. Your turn, number 2. Now, any of this fraction work, I don't expect you to do any arithmetic by hand. You can if you want, but you can just do this in the calculator. So if you want to do this in the calculator, do 2 divided by 3, hit enter, get a decimal, and then add 1 divided by 4. It'll give you another decimal, then convert that decimal back to a fraction. I'll go ahead and get a common denominator. So that'll be 12. So multiply this by 4 over 4 gives us 8 twelfths. And 3 over 3 on the right gives us 3 twelfths. Add them together, and we get 11 twelfths. Now sometimes we're going to have like terms on one side of the equation. If you see that, we're going to simplify that side of the equation. Right? So think of this equal sign as being a big divider. When we start simplifying, we're not going to cross the divider. We're going to simplify this side separately from this side. So 3x minus 2x is a single x. And as it turns out, that solves the equation. Your turn, number 3. Negative 4x plus 5x equals negative 5. Simplify on the left, negative 4 plus 5 is 1, so we get a single x there, and x equals negative 5. All right, this one will require a little bit more work. Negative 5 plus 6 is 1, so that's a single x. X minus 7 equals 1. And now this looks like the equation we started with. So sometimes you can simplify to make it look like one of these. So now we'll add 7 to both sides. All right, always doing the opposite of what's there. We have a negative there. That means we need to add to both sides. This will cancel out, and x equals 8. All right, let's check. I'm going to take 8 and plug it in here, so that gives us negative 5 times 8 minus 7 plus 6 times 8 equals 1. Negative 5 times 8 is negative 40 minus 7 plus 6 times 8 is 48 equals 1. Let's see. All right, so we combine these. 48 minus 40 is 8, minus 7 is 1. 1 equals 1, that checks. So x equals 8 is correct. That brings us to your turn, number 4. On the left-hand side, 15 minus 14 is 1, so that's a single x. Keep the 18 plus 18, negative 27. All right, now we have a positive here, so we need to do the opposite and subtract. Combine those, we get x equals negative 45. Now, up till now, the coefficients on the x's have always been 1. But of course, that always will not be the case. So in that case, we're going to have to use the multiplication property. So just like with addition and subtraction, we can multiply both sides of the equation by the same number. And it works for division too. And there's a couple of different ways you can write this. So example 5a, now we have a coefficient on the x, 7, and we need to get rid of that. So one way to get rid of something is to multiply by its reciprocal. So 7, if we multiply by its reciprocal 1/7, 7 times 1/7 is 1. So that gets rid of the coefficient. We're left with just, let's see, I gotta do it on this side too. All right, so that'll get rid of that, leaving just x on the left. Now we have to multiply both sides by 1/7. So that gives us x equals 28 times 1/7 is 4. Another way of writing that is just to divide both sides by 7, and x equals 4. So you could write them either way. Your turn, number 5. Right, got 3x equals 21. Divide by the coefficient on the variable. So divide by 3. And x is 7. All right, now we've got a negative coefficient, negative 5 on the x. So that means we need to divide by negative 5. And on the right, positive divided by negative is negative, so x is negative 6. And if we plug it back in, negative 5 times negative 6 is positive 30. Your turn, number 6. All right, negative 12 on the x is the coefficient, so we'll divide by that, and you get x equals negative 5. We won't always get a whole number. Right? Sometimes we'll get a fraction. So when we divide here by negative 8, that gives us negative 20 over 8. And then make sure you reduce any fraction to the lowest terms. This can be done in a calculator. Do 20 divided by 8, and then convert back to a fraction. And it'll automatically give you lowest terms. Now if we divide top and bottom by 4, that gives us negative 5 halves. Your turn, number 7. All right, divide both sides by 28, we get 6/28. Divide top and bottom by 2, and we get 3/14. We may also have fractional coefficients. So that's one way they can be written, just with the variable over a number. And in order to get rid of that number, since we're dividing by 3, we do the opposite, which is multiply both sides by 3. So here the 3's cancel out, leaving just an x on the left, and negative 2 times 3 is negative 6 on the right. Your turn, number 8. X over 5 equals 4. So we're dividing by 5, so to cancel that out, we're going to multiply by 5. 5's cancel, and x equals 20. Now, if the fraction has a numerator other than 1, sometimes it's written like this. Two-thirds x equals 8. You have to be careful when writing like this. Make sure the x is either right along with the divisor line or in the numerator. Never put x in the denominator. That means something completely different. That means 2 divided by 3x, and that's not what we're doing. We're taking 2/3 and multiplying by x. All right, now, to get rid of the fraction, multiply both sides by the reciprocal. That way the 3's cancel and the 2's cancel. All right, so those fractions are gone, leaving just the x on the left. And here we got 8 times 3 is 24, divided by 2 is 12. If you prefer to do this in 2 steps, you can. So we can get rid of the 3 by multiplying. And then divide by 2. Some people prefer to do it like that, and that's fine. Let's try both of them. Your turn, 9a. We're going to clear the fraction first. So for 4/5 x equals 40, we clear the fraction by getting rid of whatever's in the denominator. So multiply both sides by 5. The 5's cancel, leaving just 4x on the left. 40 times 5 is 200, divided by 4, and x equals 50. So that's one way to write it. You can also use a reciprocal if you like. So flip that fraction over. multiply both sides of the equation by 5/4. 4's cancel, 5's cancel, leaving just x. And then here we've got 40 divided by 4 is 10, times 5 is 50. So same answer either way. Now some are going to have a negative sign on the variable. Keep in mind that's just a -1 coefficient. So that means what we can do is multiply both sides by -1. That'll turn this positive and the other side negative. So x is -12. Your turn, number 10. Another way of writing it is to divide both sides by -1. Negatives cancel here, negatives cancel here, so x is +8. And for the next one, we're going to combine those last two topics together. Now we've got a negative fraction on the variable, so negative fractional coefficient. So in order to get rid of that, we're going to multiply both sides by the reciprocal, keeping in mind that the reciprocal keeps the sign of the original fraction. So if we have a negative fraction to start with, coefficient, or the reciprocal will also be negative. That way the negatives cancel, the 2's cancel, and the 5's cancel. So everything cancels on the left. And then over here, we got 12 divided by 2 is 6, times 5 is 30, with a negative there. So -30. Your turn, number 11. Reciprocal of -3/7 is -7/3. All right, everything cancels on the left except the x. And on the right, we got 6 divided by 3 is 2, times 7 is 14, so -14. All right, now we're going to look at some equations that require more than one step to solve. Everything we've seen so far has been these one-step equations. Now, here's another reason why order of operations is so important. When we are evaluating expressions, we're going to do order of operations in the order that we've seen before. But when we're solving equations, we're going to do reverse order of operations. And that tells us whether or not to add or multiply first. So we're always going to start with addition and subtraction if possible. Example 12 has 5x minus 8 equal to 22. Now if we started with dividing out the 5 on the x variable, we'd have to divide all three terms by 5. We're going to get a bunch of fractions. It's going to be a big mess. Don't do that. Instead, let's get rid of this first. Let's get rid of that -8. So we're doing the opposite, so add 8 to both sides. So this goes away, cancels out, leaving 5x on the left and 30 on the right. So by adding or subtracting first, we eliminate a bunch of problems. Now we can divide by the coefficient on the variable, and x equals 6. All right, just check. I'm going to plug it back in. 6 times 5 is 30, minus 8 is 22, so that works. Your turn, number 12. So we're going to start with constant. Get rid of that by subtracting on both sides. And get negative 12. And then divide by 4. X equals negative 3. Now the variable can occur on either side, and there might be fractions. 5 equals 2/7 x plus 1. All right, so we'll do addition, subtraction first. Let's get rid of that 1. Minus 1 on both sides. Got a 4 on the left, 2/7 x on the right. All right, now we have a fractional coefficient, so let's get rid of that by multiplying by its reciprocal, 7/2 on both sides. So 7 and 2 cancel on the right. Now we've got 4 divided by 2 is 2 times 7 is 14. X is 14. And it doesn't matter if you write it 14 equals x or x equals 14. Your turn, number 13. All right, start with addition, subtraction. We have a negative 4. We're going to do the opposite, so add 4 to both sides. That gives us 10 equals 5/3 x. And we need to get rid of that coefficient, so we'll multiply by its reciprocal, 3/5. Threes cancel, 5s cancel. 10 divided by 5 is 2, times 3 is 6. X is 6. All right, let's try this. 6 plugged in here. 6 divided by 3 is 2, times 5 is 10, minus 4 is 6. So that works. Now sometimes we'll have variables on both sides. All right, so we're going to combine the like terms together. All right, I've got a positive 5x here. Now we could have subtracted 9 from both sides, but that just leaves it with 0 on the left, and then we'd have to move something over anyway. So that's more work that way. So what we want to do is get all the variables on one side, all the numbers on the other side. All right? So that's why we want to take the 5x, get rid of it, move all the x's to the left. That leaves us with just the number on the right. So 9x minus 5 is 4x on the left. And over here, be very careful. That negative sign is attached to the 28. It has to come down with it. So negative 28 on the right. A big mistake I see people make is forgetting about that negative, just bringing down positive 28. Divided by 4 on both sides, and x equals negative 7. Your turn, number 14. All right, let's get a number on the right, no numbers on the number on the left, no numbers on the right. Let's get this 4x out of here. That gets all the x's to the right-hand side. So 45 equals 3x. All right, now divide by the coefficient on the variable, and x equals 15. Let's make sure this works. We got 4 times 15 is 60. Plus 45 is 105. On the right-hand side, 7 times 15 is 105. So that works. And that's it for today. We're going to be working with some more complex equations next time, so make sure you master this stuff.